okay, to distinguish with the other one. So this declared a class object, my in file. And then it looks like for this one, you don't need to use this. Okay, now if stream okay, the syntax is a little bit different here. You declare that and then give the file name here, my in, okay, let's say the file name is called input 1.dat data. Okay, okay, now I was a little bit hesitating. Now I understand. For an input file, the syntax is a little bit different. Why? Because if it's an input file, the default assumption is that it already exists. Okay, so you don't need to use an action like that. You just declare, I'm going to use that file that exists in the current directory as my input file. So you don't need an explicit opening statement. Okay, but it is also a good program practice to check it indeed exists. So we use an if statement. Okay, even though it's not mandatory, it's a good habit. Okay, now we can say if this file, my in file, the function is called is open. Okay, do some action. This action is to check whether the file is open or not. Okay, if the file is in the directory is open, this will return a value of true. When it's true, now we execute what's inside the block. Okay, and then you can say get my in file and then line what this statement will do is to get the first line in the data file and get the first line from the in file. Okay? And put the value in this variable. Therefore, before that, we need to define a string type of variable line here. Okay. So again, remember this get line action is going to get one line from the file and put it here. Okay. And now you can then print this just to check it get exactly what we want on the screen, okay? This will print whatever value in the variable line there and onto the screen and see if the file is opened correctly, and you read the first line of the file and check the content of the file. Okay? And then let's say, once we are done with that, we also need to explicitly close the file. So this is my in file dot close parenthesis semicolon. Okay. Now remember I mentioned if this is an object is a thing, dot behind the description behind a dot means an action. So this is check whether the file is open or not. This one is close this file. These are called member functions and class functions. Okay. Any functions, some functions like this one, it is a function. Take some variables. Some functions take empty variables. So, but even if empty variable, you still need to carry these parentheses. This is a very important point. And also, it serves the practical purposes to distinguish a function from a variable or class. Okay? When you see something that followed by a parenthesis, you know it is a function, it's an action. When you see something without parenthesis, you know it's something. Okay? That also is important. Now, if you combine these two together, you know how to read from a file, do something, and put the output into an out file, right? Okay. So this is important because I think it's always good to work with output file, input file. And there are some more commands and descriptions of the input and output files in the handout. I'm going to skip these. Okay. A lot of those advanced features we don't really need it. Okay, next I would like to talk about statement and flow control. This is in chapter 8. I could say the reason a program is useful is because it has the ability to use flow control. Any useful program, there will be a lot of flow controls, because flow control means depending on the condition, you do this. If the condition changes, you do that. Okay, that's very, very useful, right? Any one-dimensional flow of execution is not so useful. Any conditional flow will be much more useful, okay? And if you look at any useful program, there will be a lot of conditions. Depending on what the input is, the flow of the execution will be different, okay? All these are achieved by flow control. Okay, the first flow control I'd like to describe is the if and else statement. The if statement is very simple. The syntax is this. If and the condition is inside parentheses, and then you say statement. Okay, so that's the syntax. You can say this is condition. The execution is this. The computer will check the condition first. If the condition is true, then it will execute a statement. If the condition is false, it will do nothing, just skip that statement. So it's as simple as that. Okay? Let's say, for example, if variable xx has the value of 100, then it's going to see out, it's going to print out the sentence says x is 100. Okay? Okay, let's check. First, whatever current value x has, the computer is going to check whether it's equal to 100. If it's equal to 100, the expression has a value of true. It returns a value of true. When it is true, then what is inside the if block, which is here, will be executed. So it's going to output that. When x is 99, for example, this becomes false. That will be skipped. Okay. For a single statement like that, the curly bracket here, the curly brackets are optional. You can leave them out, but it is always, for readability, it is always good to have a pair of curly brackets. And when you have two statements that you want to be put on the control of if, now the pair of curly brackets are necessary. Okay? And then you can say, after print this out, you can do another thing, see out, you say done. Then both those statements will be under the control of that condition. Okay? Therefore, the curly brackets are necessary. Another thing I like to draw your attention is that there's no semicolon here. If you put semicolon here, what will happen? Can you guess what will happen if you put here? The program will run and then run through these several lines. What will happen? Well, if you put semicolon here, that if statement, it will still judge the condition, but this is an empty statement. So whether it's true or not, if this is true, it's going to execute an empty thing, which is nothing. When it's false, of course, it's going to skip that. It's also empty. Then you move to here, this is no longer under the control of if. Okay? So this block is like independent, unconditional statement. So these two lines will be executed all the time because there's no condition anymore. That semicolon terminates the if statement. Okay? Therefore, be very careful here. Or another way to think of it, even though we developed the habit of putting semicolons in every statement, the if here, up to that point, is not a complete statement. Okay? You need to carry this to be a complete statement. So that's why the semicolon comes here, not there. This is an easy mistake from past experience. I noticed that many students, they say, okay, everything at the end of the line, we need to put a semicolon and put it here. And then the result is not what they expected, so they got confused. So I like to point out, we don't put a semicolon immediately after the condition, okay? It's not complete yet. We only put it here. Okay, so this is the if statement, simple enough. Well, sometimes we want the if statements to be more complex. We want to do a two-condition thing. Let's say if x is indeed 100, we want to do that. If it's not, we want to do something else. You can achieve that by adding the else statement. So if and else together. Now you can say C out x is not 100. Okay. With the else, if you have if and else, one of the block will be executed depending on the condition. If the condition is true, this block will be executed. If the condition is false, that block will be executed. Okay? So it's a binary kind of thing, judgment. And because the if and else, just the syntax is very similar to our daily life language, so most people have no problem understanding this at all. Okay? And again, don't put semicolon here, and don't put semicolon here. If you put here, it will be an empty else statement. And this is no longer under the control of that. Okay? So this is the if control statement. And then there is another iteration statement. The while statement. And the syntax is this. Okay? Let's say, for example, we declare an integer and which has the initial value of 10. And here we say y n is larger than 0. Out less than and less than okay. Let's look at this program, this code block. By just looking at that, let me explain what the while statement is. The while statement will first evaluate the condition inside. If it's true, it will do this. After this is done, it's going to evaluate that again. If it's true again, do this. And come here. True again, do that. So it will continue to do that until that condition becomes false, and then you will skip that and go outside. Okay? All right. Now, if a block of program is like that, what do you guess the input will be?
Count down from 10.
Okay. First time n is 10. This is true, right? So you will output value of. So the output will be this. The first time we have a 10, and then it is followed by a comma 10, and then this will decrease the value of n by 1. So it becomes 9. 9 is still larger than 0, so it's true, so it gets executed again. You print out the value of n, this time is 9, comma, and then it becomes 8. So you will keep doing that. So 10, 9, 8, up to 1. When it is 1, what happened? This becomes 0. So you go back here. It's no longer true. You will skip and go out here and print this out. And then lift off. So that's the output of that program block. Okay? Alright, so you can see the difference between the while and the if. What is the main difference between while statement and if statement?
If only executes once.
If only execute once. Okay, while is a looping statement. What is the danger of using while statement?
stuck in it.
it can become a dead loop. Because for some reason, if you forgot that, what will happen?
It's always going to
Keeps
be
printing
10.
10.
It will be 10, 10, 10 until you turn off the power or kill the program. Right? It becomes a dead loop. If you write a file, you keep writing that, you will consume your whole hard space. Something is wrong. Okay? So, one thing you need to do is when you have a while statement, we usually call this the index, the condition index, n here. Always make sure the condition index is alterated or is changed inside the execution block. You need to do something with this n. Okay? If you don't do something with this n, it will become either a dead loop or it become an empty loop. If from the very beginning this is false, it will not be executed. But if this is true, because the index is never changed inside the program, it will be executed forever. Okay. All right. Then there's another one called the do-while loop. Okay, this while loop can be changed to a do-while loop. For example, okay, we declare a variable integer and initialize the value to 10. Okay. And then we can say do cout and less than comma semicolon and then negative n while n is larger than 0. And then cout less than lift off slash like that. If we rewrite the code from the while loop to a do loop like this, for this particular case, the output is exactly the same. Okay, like this. So how is a do while loop executed? It will first execute that statement once, then check the condition. If the condition is true,